genetics is clearly something that we can tie neatly back to home, family, mental health, making home, relationships, etc. Quantum physics may be more confusing. Let's just say one version of ourselves is here this evening, while another may be sitting on your couch at home. I hope that Sean can help me to connect the dots here. In all seriousness, tonight you will hear from two extraordinary thinkers whose list of accomplishments is so long that it's better to hear them speak than for me to go on and on so quickly. Carrol Zimmer is a journalist who describes his journalistic beat as life or what it means to be alive. His column Matter has appeared regularly in the New York Times since 2013, along with writing for countless magazines and publishing 13 books about science. He's also won numerous awards, including the 2019 National Academics Communication Award for She Has Her Mother's Laugh, The Power, Perversions, and Potential of Heredity. Tonight, he'll be in conversation with Sean Carrol, a theoretical physicist at the California Institute of Technology. Carrol also is the host of the podcast Mindscape and the author of 4 books, including his most recent, Something Deeply Hidden, Quantum Worlds and the Emergence of Space-Time. He has received many awards and fellowships from such places as the American Institute of Physics and the Royal Society of London and NASA, to name a few. Without further ado, please welcome Carrol Zimmer and Sean Carrol.
Thank you very much. I love being back at the LA Public Library. They like having me back because I always tell the story of when I got into science, it was because I hung out at the local public library in Bucks County, Pennsylvania, reading all the physics books and so forth. Now, as was mentioned, I am a podcast host and author who also does theoretical physics in his spare time. But we are mostly here to talk about biology with Carrol, but we recognize that biology is a subset of physics. So there will be occasional eruptions of physics into the biology conversation.
We just fit in a little corner of your world, don't we?
Yeah, you know, it's a certain kind of applied physics.
Yeah.
You know, it's a little bit messy. Darwin had this idea of natural selection, very good. And then it was Mendel and others that actually isolated genes. And then it was Crick and Watson and Franklin and others that said DNA.
Yeah, you're going great.
No, you know, I just gave the words. You got to give the ideas, man.
Yeah. So I mean, the irony is that Darwin was actually really important for framing heredity actually as a scientific question. We have a pretty small genome. Lilies have like 20 billion or something like that.
Yeah, so like we're
lungfish are like 100 billion.
It is weird, right? We're not like the best at the.
Well,
we don't win the DNA battle.
Size is everything, you know.
Size is not everything. Okay.
Know. For plants, yes, epigenetic inheritance is really important, and it's been proven and documented over and over again. And for humans, it's much fuzzier.
Yeah, we just don't know yet.
Well, there have certainly been people who have have fertilized human eggs, and then have used CRISPR to alter genes, and then they haven't actually like implanted that in someone. They've just like looked at them in a dish and you can do some very important research to understand the earliest stages of development. Say like, I'm going to shut down this gene. Does that change the way that this little embryo develops? But a human embryo can only survive for maybe a week or two in a dish and then just peters out.
We're getting good at editing the genes, right? Like we can just go in and dial up whatever kind of baby we want. It's like choosing a character in a video game.
Really?
That's what I hear on the internet.
Yeah. Wow. Thank goodness for the internet, huh? Yeah. It's what a wonderful way to
disseminate. Your job is to set me straight about these things.
You're totally wrong, Sean. No. If you've got a parent who has Huntington's disease, you have a 50% chance of getting Huntington's disease. And if you inherit that variant, we know exactly where the variant is on the gene. So what do you do with that? What are you supposed to do knowing that you have like a 10% higher risk on average of this disease?
With the advent of gene editing technology and CRISPR-Cas9, do you think that we're going to enter an era of what I call hyper-evolution?
If CRISPR became like, I don't know, as ubiquitous as vitamins or something, then yeah, maybe. If you read some of the ancient Greeks, you get the impression that, well, people look like each other through the generations just because they grew up in a cold place or a warm place or so on. And, You know, there's nothing really the way we think about heredity that you can really find in there. We use the language of blood all the time. You know, it's in my blood, or I've got this, you know, this such and such blood running through my veins. That's a very particular, you know, Western cultural product. I mean, and you can sort of see where it pops up in the Middle Ages. And it's mostly sort of a justification for kings saying, like, this is why I get to be king. There are anthropologists who've studied some villages in Malaysia where the bond that you have with your parents is not because of blood, it's because of food. It's because of of nursing and the food that you eat, and it's the same food coming from the same soil, so you all have that same bond. So they don't talk about blood. Part of what I'm trying to do in my book is I'm trying to sort of get people away from saying, like, heredity is simple and it's just like one way. So, you know, we think of heredity as just flowing sort of down, like a waterfall, like one generation to the next and the next and the next, and that's it, and there can't be any other way, you know. And in fact, if you think of heredity as how you end up with, you know, we can talk about genetic heredity in particular, and so people say, like, well, it only comes from your parents, and that's just not true. So there are people who were you know, in the womb, they were twins, and twins may trade cells, and those cells get incorporated into each other, and then one of the twins may die. You know, people may just not even know there was a twin, and then that person is born, and they actually have the cells of two different people in them. And so they're chimeras. So, like, in your microbiome, there's a constant war going on right now. Like, in your mouth,
you have no idea.
Now, there are billions of viruses that are attacking billions of bacteria in your mouth right now. And each species of bacteria is attacked by a particular species of virus. It's a bloodbath in there. The viruses are
making me a little self-conscious.
Yeah, well, hey, I just, you know, so the viruses are invading the bacteria and basically taking over the genetic machinery, making lots of copies of themselves, and then the microbes just blowing up, and lots of viruses are coming out to invade other ones. So that's a very strong evolutionary pressure, and evolution has basically given some bacteria the ability to fight these viruses.
Rapidly improving technology and editing and things like that. How do you think these old ways of thinking will affect our debate about how we use these newer technologies?
As far as sequencing genes or CRISPR, are we going to find that there is an ideal set of genes that we can have a goal toward?
I think we got through 7 different people asking questions, so statistically 2 of you are chimeras.
Yeah.
And I wanted to thank Carrol very much for this wonderful conversation.
Thank you.
And the LA Public Library for being a wonderful venue and hosting all these wonderful books and events. And of course, thank you very much for coming out here tonight. See you next time.
Thank you.